Hi chemists. Right then, first question is about, on these organic questions up to and including esters, hexane versus hexene, alkane versus alkene. Hexane saturated, hexene unsaturated. You have to draw the formula. So I know that hexane is CnH2n plus 2, so that's going to be C6H14. Hexene is C6H12. Remember, CnH2n for an alkene, CnH2n plus 2 for an alkane. This question is entirely about hydrocarbons, chemicals made of hydrogen and carbon only. Bromine water. Bromine water comes up an awful lot. This is orange, and this is the test for alkenes. So when you add bromine water to an alkane, you get no change. So no observable change, or you could say bromine water stays orange. Hexene, you get the change orange to colourless. You must say both, orange to colourless. You're not allowed to say turns colourless. All right then, this is a comparison question. We're going to compare ethane and ethene, an alkane with an alkene, and we should refer to structure and bonding. When we're doing comparison, we need to make sure we do similarities and differences. So already I'm thinking I need similarities and differences in structure and bonding, and similarities and differences in their reactions. So let's just have a little look at similarities and differences. All right, structure and bonding. Similarities, both made of carbon and hydrogen. Both made of carbon and hydrogen, okay. They've both got 2 carbons, all right. Differences, ethane has got, I don't know if it's the best way of organising it, ethane has got 6 hydrogens, ethene has got 4 hydrogens. I know these sound quite simple, but I'm doing them. Similarities between the both. Similarities, they both contain covalent bonds. They both contain covalent bonds, so similarities and differences. However, ethene has got a carbon-carbon double bond. Ethane is all single bonds. I could write unsaturated for ethene. I could write saturated for this. This isn't the best way of structuring it. I'm already seeing that. What else can I say about their structure and bonding? They are both simple molecular substances. So therefore, they will both have weak intermolecular forces between their molecules. Anything else I could say there? Possibly, but I think I've done enough on structure and bonding. Right, reactions then. Reactions. Well, the thing is, right, alkanes don't really do many reactions, but they do combustion. I can set both of these on fire. All right, so they both do combustion. They can both do, I suppose, complete combustion. And if you burn them, you're going to make carbon dioxide and water. That's cool. But I also know that ethene tends to burn with a smoky flame. That was on your notes. So it tends to do more incomplete combustion. So you can make carbon monoxide or carbon. Right, reactions again. So that's the end of those reactions. You can set it on fire, that's about it. I could also write about here, ethene does what we call addition reactions. So I could write about, you can add hydrogen to ethene, you could add bromine to ethene, you go orange to colourless, and you could add water to ethene to make alcohols, and ethane doesn't do that. The mark scheme in the back has just got a list of things like this, and if you rattle off as many similarities and differences, you'll be fine. But look what I noticed, and look what I did first. I said compare means similarities and differences, and I said I'm going to do the first bit about structure and bonding, which is the bonds itself and simple molecular, and then the reactions. In summary then, alkanes, all you can do to them is set them on fire. Alkenes, you can do loads of cool chemistry. Let's move on. Right, I'm going to try and speed up, but we all know how that normally goes. The question about carboxylic acids, we've just done this in a lesson. So carboxylic acids look like this. They've got OH like that. So you've asked to do the formula of methanoic acid. Now, we did this in class. Methanoic acid has got one carbon, so COOH, and it has a hydrogen there, HCOOH. There it is. And that's how we would draw it. This has got 1, 2, 3, so that's propanoic acid. Propanoic acid. All right. Complete the table above, which I've just done. 2 marks. Ethanoic acid ionizes in water. I'll tell you what, it partially ionizes in water. The equation for the reaction is this. So there's the hydrogen on, and there's the 2 things separated, pens and lids. Explain how the equation shows that ethanoic acid is a weak acid. Right, that there shows it's a reversible reaction. Okay, so I'm going to say that it's to do with that reversible arrow, but I'm going to look up this answer because I'm not sure. All right, how do I say that? So I'm going to look to the back. What do they want from me? That's what I want to know. That was the tone for the end of lunch, so I've not got very far through this. Right. The reaction is reversible, 1 mark. So that shows that it's only incomplete or partial ionization. So I didn't say that. All right. Explain how the equation shows that ethanoic acid is a weak acid. It's a reversible reaction, so it's only partially ionizes. I suppose that wasn't said here, it just said ionizes, didn't it? So that tells me that it partially ionizes in solution because of the arrow. A student adds a solution of ethanoic acid to zinc carbonate in an open flask on a balance. Right, I showed you this in class. When you add a carboxylic acid to a carbonate, what is given off is carbon dioxide. All right, it's going to fizz. So carbon dioxide will be given off in this reaction. So the mass of the flask will decrease because carbon dioxide is given off. Explain what happens to the mass of the flask and its contents during the reaction. The flask and the contents will get lighter. Carbon dioxide is made. Right, what am I missing there? 3 marks. What am I missing? I'm not great at these questions, am I? I'm not confident I'm getting all 3 marks, which is why you've got to see me go through this. All right, mass decreases. Yes, carbon dioxide is produced and escapes. So I said given off. Maybe I didn't emphasize it enough. It escapes. Carbon dioxide is made and it escapes. Okay. Next little bit then. The student compares the rate of reaction in zinc carbonate with methanoic acid and ethanoic acid that are the same concentration. The rate of reaction with methanoic acid is greater than the rate of reaction with ethanoic acid. And I've written the answers in here for you. What I've seen from this table is methanoic acid has got a lower pH. That means it's more acidic and it has a greater concentration of H+ ions in solution, so you get more frequent successful collisions. This is a rates question. Okay. This is straight off the video about esters. If you react ethanoic acid with ethanol, you will make an ester called ethyl ethanoate. This is the only ester that you need to know the name of, ethyl ethanoate. All right? The ethanoic acid gives you the ethanoate bit and the ethanol gives you the ethyl bit. So, if you have to name an ester, ethyl ethanoate. Next little bit then. Hexane dioic acid and ethane diol join together to form a polyester. Oh yeah, sorry. You don't need to know that. Yeah, you do need to know this bit. Ethanoic acid and ethanol join together in the same way to produce an ester, which is the displayed structural formula of the ester produced when ethanoic acid reacts with ethanol. So I'm looking for 2 carbons joined to 2 carbons. Let me have a little look. That's got that, but it hasn't got the ester functional group. If you look down the bottom, here it is. If I cover this bit up, there's the ethanoic acid that it came from. There's your ethanoic acid, and you cover this bit up, and there's the alcohol. There's the ester that's made from ethanol, 2 carbons, and ethanoic acid. I just realised I've kept that off the screen. That wasn't great. Okay, next, I've got to get my form in very, very soon. A hydrocarbon has the formula C6H14. Name the 2 elements in the hydrocarbon, carbon and hydrogen. How many atoms are there in one molecule of this? 6 plus 14 is 20. C6H14 is a member of a homologous series. What's the general formula for the homologous series C6H14? That's CnH2n plus 2. Going to pause there. Which homologous series has C6H14 as a member? That is alkanes. They want me to show the structural formula of C6H14. This is a foundation paper. Just show all of the bonds being formed. Petrol contains C6H14. What's the general name used to describe petrol when petrol is burned? That's a fuel. This is a cracking reaction. C6H26. So we're going to make C6H12. That's the tone. Got to get you in. Right, going to carry on recording this next bit. My phone haven't quite left the room yet. Hi, Bill, you alright? You want to be on video? Say hello. Hello. Thank you. Right, this question is about ethanol. The formula for ethanol is C2H5OH. Complete the structural formula. Just need to put 2 bonds in there, single bonds. What's a use of ethanol? Well, we can use it as fuels. We can use it as something else, can't remember. But we can use it as a hand gel to kill microbes. Ethanol can be produced from sugar solution by fermentation. What must be added to sugar solution? Yeast. Right, got them done. Pause. So now, after school, I'm going to go through the rest of these questions. Question 5. So this is to do with ethanol and alcohols. Let me remind you about alcohols. Alcohols have got OH minus functional, OH functional group. The diagram below shows the displayed structural formula of ethanol. Draw a circle on the diagram around the alcohol functional group. You need to circle the O and the H. An ethanol molecule contains atoms of 3 different elements. Complete the table to show the name of each element. Oh my goodness, so this is foundation level, okay? Carbon, how many carbons are there? 2. Contains hydrogen, 1, 2, 3, 4, 5, 6, and they're hydrogens. And this is oxygen, so that's clearly foundation. Don't be too made up if you got that right. Ethanol removes grass stains from clothes. Okay. What type of substance is ethanol when used to remove grass stains? That is a solvent. So it dissolves the grass stains. That's a solvent. Wine contains ethanol. Wine is produced from grape juice by fermentation. Now, I told a story about me doing fermentation in a bath in university, and it involved sugar and it involved yeast. Complete the sentence. Grape juice can be fermented to produce wine because grape juice contains, now it would allow sugar, but you can also have glucose. I would prefer in triple that we wrote glucose. What is added to grape juice to cause fermentation? That is yeast. Remember, it also has to be anaerobic. Ethanol reacts with ethanoic acid to produce an ester. So this is the bit that I asked you to go and look at. We've got ethanol. There we go. Reacts with ethanoic acid. I'm going to draw ethanoic acid this way round to produce an ester. What is the name of this ester? That is the name of the ester, ethyl ethanoate. These 2 chemicals smash together to form ethyl ethanoate. I'll draw it out in full here. Okay, so you have to know the name of a phone. Sorry about that, my phone died. Right, ethanoic acid reacts with sodium carbonate. I showed you this at the front of the room. You take ethanoic acid, you react it with sodium carbonate, they fizz, they give off carbon dioxide. What's the name of the liquid produced? Well, the liquid is water. It didn't say what's the name of the solution produced. This would be called sodium ethanoate, but it didn't ask that. It was being tricksy. Right, the name of the liquid produced is water. Question 6. Right, this question is about organic compounds. Butane is an alkane with small molecules. Butane can be used as a fuel. Ethanol burns in oxygen. Ethanol burns in oxygen. C2, 2 car. I've got to balance the oxygens. I'm going to count them up on this side. 1, 2, 3, 4, 5, 6, 7. There's 1 oxygen over here, so I need to balance with a 3. Okay. Next, 2 processes for producing ethanol are fermentation. That was me. Bath, fruit, yeast, cling film, anaerobic, very slow, hydration, blah, 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 ethene and steam. Advantages, 2 advantages and 2 disadvantages of using fermentation to produce ethanol. An advantage of using fermentation is that the raw material is renewable. An advantage of using fermentation is the energy requirements are low compared to the energy requirements being high, so that will cost you less money. Disadvantage is fermentation is a very slow process as opposed to hydration, which is very fast, so you'll have to wait a long time. And another disadvantage is when you do it in a bath like me, fermentation, you get very low purity of ethanol, whereas hydration is a very high purity of ethanol. Okay. So there we go, fairly straightforward question there. This question is about cycloalkenes. Now, a cycloalkene is not on the specification, but is a compound which is cyclic, like this, and it has a double bond in it. Each carbon will form 4 bonds, like that, to hydrogens, and you have this double bond here that will act like a double bond. So it will do things like it will decolorize bromine water. It will add other elements across it. So anyway, it says, describe a test for the double carbon bond. Test bromine water or add bromine water. Result, orange to colourless. We've already noticed this question has come up before, so it's important. Orange to colourless. The table below shows the name and formula of 3 cycloalkanes. Cyclobutene, that's 4, like that, by the way. Butene, it's got a double bond. Each of these has got hydrogens on. Cyclobutene. Cyclopentene, 5 in a ring. Cyclohexene, 6 in a ring. Determine the general formula. C4H6, C5H8, C6H10. It's actually this, CnH2n minus 2. So you double the number and take away 2. All right, I don't know if you could work that out. This is the displayed formula of cyclohexene. Chlorine reacts with cyclohexene to produce a compound with this formula, C6H10Cl2. So it looks like we've just added chlorine. We've gone from C6H10, we're going to add chlorine, and we're going to make C6H10Cl2. What happens is you add the chlorines over the double bond. So I'm going to put all the hydrogens in that were there. This is where the double bond was. It's now going to have a hydrogen and a chlorine. It's going to have a hydrogen and a chlorine, and this will all be the same. If I go back to that drawing over the page, we're just adding a chlorine here, adding a chlorine there, and making that a single bond. All right, you haven't, in your notes, we talk about addition reactions. It just doesn't matter that it's in a cyclic compound. Calculate the percentage by mass of chlorine in a molecule of this. All right, gosh, I don't know if we've got time to work this out. Cl2. So in this molecule, I'd have to work out the total mass of that molecule. Let me just check the answer in the back, just to speed it up. Question 7, 153. Whoops, not the camera. This whole molecule weighs 153. That weighs 153. And there's 2 chlorines in there, which would cumulatively weigh 71. 71 out of the 153 would give you the percentage by mass. Right. This question you've had in your notes. This is a Herc-Cattle question. Heat, evaporate, rise, cool, condense at boiling point at different levels in the column. You've got that question somewhere in your book. Please have a little look through that. Fractions from crude oil can be processed to produce feedstock for the petrochemical industry. Which 2 are useful materials produced from this feedstock? Solvents and detergents. All right, that's straight out of the specification. I'll get that printed for you so you know the answer to that. Right, we've got petrol containing a hydrocarbon with this formula. Complete the equation for the complete combustion. So when you burn something, you react it with oxygen. You're going to make CO2 and H2O because it's complete combustion. If I've got 9 carbons, I'm going to make 9 carbon dioxides. I've got 20 hydrogens, I'm going to make 10 H2Os. I'm now going to balance the oxygens. There's 18 oxygens here, plus 10 is 28, so I'm going to need 14 O2s. We've done examples like that in our books. Right. A student predicted that heavy fuel oil here, which has got more carbons, is more viscous than kerosene. The student's prediction was correct. Justify the student's prediction. it's got longer molecules, and longer molecules are more viscous than shorter molecules. I'm pretty sure that's the answer. Check in the back. Name the process which produces smaller hydrocarbon molecules from heavy fuel oil. That's going to be cracking. Give the conditions used in this process. Well, we're going to need heat, and you can either say steam or heat and catalyst. Choose one or the other. Choose one or the other. Okay. Hydrocarbon molecules containing 7 and 8 carbon atoms can be produced when heavy fuel oil is processed. Which pair of hydrocarbon molecules would both turn bromine water colourless? There's this bromine water thing again. So we're looking for alkenes. Alkenes, so 7 and 14, that's an alkene. 8 and 16, that one. That's an alkene, that's an alkene. All right. That is ethene. That's ethene with its double bond there. Let's have a little look. When bromine water is added to ethene, bromine water comes up again, colourless. Which of the following shows that chlorine reacts with ethene? What's the correct structural formula for the product? Right, here's ethene. Looks like that. And I'm going to add chlorine over that double bond. So I'm going to do that. It's going to be this. I'm looking for this. That one. 2 chlorines added over the double bond. How much more have I got to do? Quite a bit, and I'm running out of time. So, name the process used to produce ethene from large hydrocarbon molecules. That's cracking. All right, this idea of large hydrocarbon molecules being broken down. Cracking, we've done this question before. Heat and steam, heat and catalyst. Right, leave that question out. That's rates of reaction. Ethanol can be produced by sugar solution by adding yeast. Name this process. Fermentation. That was me in the bath as in university again. Butanol, that's an alcohol, can be produced by sugar solution by adding bacteria. Sugar solution is broken down in a similar way by bacteria and by yeast. Suggest the reaction conditions needed to produce butanol by sugar. Right, anaerobic. We're applying our knowledge of my bath. Anaerobic and warm. Something like that. Not too hot because you'll denature the yeast. Right. When butanol is burned in a car engine, complete combustion takes place. Write a balanced equation for the complete combustion of butanol. Whoa, did it give us the formula of butanol? No, it didn't. So, butanol is C4. I'm going to just draw it out. That's what I do in an exam, if needed. 2, 3, 4, 5, 6, 7, 8, 9. And there'd be an OH. C4, H, 1, 2, 3, 4, 5, 6, 7, 8, 9. H9OH. Reacts with oxygen. It's going to be complete combustion. So you're going to make carbon dioxide and water. 4 carbons, 4 carbon dioxides, 10 hydrogens, that's 5 H2Os, 8, 9, 10, 11, 12, 13 oxygens, there's 1 there, so 6 O2. That's a hard question, by the way. You're expected to know that. Complete figure 2 to show the displayed structural formula of butene. Okay, they've bent it round 1, 2, 3, 4 atoms. There's going to be a double bond there because it's ene, single bonds to hydrogens. Okay, it's in a funny little square shape, but that's worth 2 marks. Ethanoic acid contains the functional group COOH. We did this in lesson today. Double bond to this O there. Again, they've bent it round in a funny way, but there's the structure. Okay. Ethanoic acid reacts with different compounds. Draw one line from each compound. So if you react ethanoic acid with ethanol, you'll make ethyl ethanoate. There's our ester. If you react ethanoic acid with sodium carbonate, you'll make carbon dioxide. That's the fizzing one that I did at the front of the lab today. This question is about monomers and polymers. We haven't done these bits yet. Draw a circle around the alkene functional group. Alkene is C double bond C. There. Okay. Describe what will be seen when compound A is shaken with bromine water. I don't even need to look at compound A. It'll go from orange to colourless, because that's come up again. Draw a circle around the ester functional group. The ester functional group is COO. Not many people know that. We did it briefly today in school and you did it on your video. Draw compound A is the formula C4H6O2 and it's flammable. Complete combustion, that's going to be O2. I'm going to put the formula in here, C4H6O2. If it's complete combustion, I'm going to make carbon dioxide and water. 4 carbons, 4 carbon dioxide, 6 hydrogens, 3 H2O. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 oxygens over here. There are 2 over here. 11 oxygens, there are 2 over here, so that's 4.5. Wow, 3 marks for that. 1 mark for reacting with oxygen, 1 mark for the carbon dioxides and the waters, 1 mark for balancing the oxygens correctly. Right. This question is about polymers. We haven't done polymers yet, but what it says here is draw a circle around the functional group. Boom. C double bond C. Central heating boilers can burn kerosene. This is a Herc-Cattle question. In the first step, crude oil is heated and the hydrocarbon vapours are formed, vaporised, evaporation. Then they're going to rise up the column, they're going to cool as they rise because the temperature gradient in the column, they're going to condense at their boiling point at different levels in the column. Boom, boom, boom. Right, nearly done. That was me done. I've now got to edit this video together. Bye.